Yes, Ashwin, everything is okay?
Yeah.
Okay, just wait a minute, है ना? Okay, let's see here. So today we have to learn the Newton's first law of motion, right?
Yeah.
Give the heading Newton's first law of motion. Okay, Newton's first law of motion. So write Newton's first law of motion. State that state that or say that it state that or say that an object at rate remains at rest. Okay, and an object in motion continues to move with a constant velocity unless a net force act upon the object. Okay, so this is the first law of motion. It says that कि mainly if suppose there is an object which is on rest, then it will remains at rest. Okay, until you applied a force, and when an object is at motion, it continues to move unless a net force act upon the object. Okay, is it clear? So suppose
Yeah.
there is an object which is at rest. Suppose as I have a pen, right? So when I place it on the table, it will remains at rest until I will apply the force on it. Okay, and when a ball is rolling, it will continues to roll unless a force act on that. Okay, is it clear? But in
Yeah.
the real world, you see that a rolling ball comes to a stop after the some time because a force act on each. What type of force act on each? Can you please tell me? That is
Left force.
friction force. So the friction force applied on the ball between the surface of the ball and the floor, okay, in the opposite direction. So that's why after some time the ball comes to rest. Okay, but the Newton sir said that ki an object will be at rest or motion, then it will continue its motion until or unless a net force act upon the object. Is it clear? So did you understand the concept of the Newton's first law of motion?
Yeah.
Huh. So do you have noted this point?
Okay. No.
If not, then please note down it. Noted? So is there any doubt?
No.
Okay, let's see here. Now it said that in other words we can say that if the net force acting on an object is zero, the body cannot brings to move or change its velocity. Okay, so in such case the acceleration will be zero. Is it clear now? So please note down this point. If the net force acting on a object is zero, the body cannot bring to move or change its velocity. In such case, its acceleration is zero. Please note down. Done.
Yeah.
So any doubt?
No.
Now let's see here. There is a note has been given. An object at rest means that it has zero velocity. Okay. Remember that the constant velocity means that there is no change in the magnitude or the direction of the velocity. Okay. If this constant
Mm-hmm.
velocity is non-zero, the motion is in a straight line in the same direction and the magnitude of velocity remains the same. Is it clear? So mainly it says that when
Yeah.
object is will be at rest, suppose as this pen is at rest, okay? So it has zero velocity. Its velocity is
Mm-hmm.
zero, है ना? And when the constant velocity,
Mm-hmm.
when we will talk about the constant velocity, it's mean कि there will be no change in the magnitude or the direction of the velocity, okay? It will be constant. If this constant velocity is non-zero, okay, it's mean the motion will
Mm-hmm.
is in a straight line in a same direction and magnitude of the velocity remains the same. Okay, is it clear now
Mm-hmm.
or any
Yeah.
doubt?
No.
Then please note this one. These are the important points. Okay,
Mm-hmm.
so I am providing the notes to you, so that's why please note down all these points. Okay, and if there will be any doubt you can
Okay.
ask me. Done.
Okay, done.
Yeah. Now let's see here as an example. Okay, if you want to note down the example, you can note down these examples. So as here it said कि a person is exerting a force on a moving box, okay, in the forward
Mm-hmm.
direction, which is equal to the force of the friction acting between the bottom of the box and the floor. So will the box continue moving or will it come to rest after
Mm-hmm.
some time? What is your opinion? Tell me. As here it is exerting the force which is equal to the force of friction. Means here net force is zero.
Mm-hmm.
So it will follow, it will move or it will come to rest after some time. Tell me.
No,
Exerting a
the
force on a moving
it
box.
won't. Oh my God. Oh, it's a moving on
Yes.
a. It's a moving
The
exerting
box is
on a
moving.
moving
है
box.
ना?
Then the the moving box will continue its path at the same velocity.
Yes. Very good. Hmm. So yeah, correct. है ना? Because here the net force is zero. To stop it, the applied force should be greater than the frictional force. Okay. So here
Mm-hmm.
the force of friction will be acting on the force in the backward direction. The two forces acting on the box are equal and opposite, right? And thus they balance each other.
Mm-hmm.
So as I told you कि net force acting on the box will become zero, है ना? And as per the Newton's first law of motion, the box will continue moving with constant
Mm-hmm.
velocity. Okay, is it clear? Now the next thing
Mm-hmm.
is कि
Yeah.
draw position, time and velocity time graphs for an object on which no net force is acting. Okay, so this is very important point. You have to note down this one. It's come in exam. Okay, so the topic should be given as position time and velocity time graph for an object on which no net force is acting. Okay, so let's see here how it will be the position
Mm-hmm.
time graph and velocity time graph. Okay, as here when no net force is acting on an object, there are two possibilities, right? Either object is at rest or the object is moving. And this possibilities can be raised, right? So which can with a constant velocity. If the object is rest, its position will not change with the time and its position time graph is shown as in the figure 16.15a. See here this one. Here is the time this side and here is the position, right? So here is the body is at rest, है ना? When the object is at rest, its position time graph will be this one. Because as when you go in the time, the position is nothing. The graph is nil,
Mm-hmm.
right? If the object is moving with a
Yeah.
constant velocity and no net force is acting upon it, it will continue moving with the same velocity, and the velocity time graph is shown as in the figure 16.6.16b. Okay, 6.16b.
Mm-hmm.
Is it clear? Velocity time graph.
Yeah.
Okay, the b1. Okay, now the position time graph. Now let's see here, the position time graph will be a straight line as shown in the figure 6.16a. Okay, is it clear? As you can see here.
Mm-hmm.
Okay now. Now let's see here, as it is showing when the object is at rest. In this one, the position time graph is this one, and this one is the velocity time graph. Okay, this is the time, this side, and this side velocity. Okay, so there will be no line between it. Okay, because the object is at rest. The second is when the object is moving with a constant velocity. So when it will moving with a constant velocity, the time position time graph will be this one. As when you increase the time, the position will also vary, है ना? As well as
Mm-hmm.
the time will increase, the position will also change, right? Okay, as you can see here.
Yeah.
Is it clear now? So here the body is constant. The
Yeah.
body is moving with a constant velocity. That's why it will be straight line like this. But when it will be the rest, when it will be at moving velocity with a constant velocity, then the velocity time graph will be like this. As here, suppose this is 2 minute, here is 5 minute, here is 7 minute, like this. So as you can see that on 2 minute the velocity is here, right? Similarly at 5 minute the velocity is again here.
Mm-hmm.
On 7 minute the velocity is again on here, right? So as you can see here, its value is same time to time. So it's mean it is moving with a constant velocity. Okay. So when it will moving with a constant velocity, the time velocity graph will be like this. Is it clear or any doubt in this graphs? You
No.
can easily draw the graphs
So
now.
these are all constant velocity, right?
Yeah, constant velocity. Okay. Here the time position graph for constant velocity. It is time velocity graph for constant velocity. Here is time position graph for when the object is at rest. It is time velocity graph for object is at rest. So please draw these four graphs and write these points. Okay. Instead of
Can you like show me the
writing
question
like
first?
this, instead of writing like this, just give the heading position time graph and draw this one when object is at rest. After that, give the heading velocity time graph when object is at rest and draw this graph. In the next point, write position time graph when the object is moving with constant velocity and draw this graph. In the next point, velocity time graph when the object is moving with a constant velocity and draw this graph. So you have to total write, you have to make total four topic, yeah, heading, okay, or points. Under that you have to draw these graphs. Is it clear now or any doubt? Please confirm me, Ashwin. Hello, can you hear me, Ashwin?
Can we just like put half
Yeah,
for
you have
like
to,
positive time for
yeah, you have to note down it in four
positive
different topic
graph
wise.
and then make a
Four different,
second
sorry,
heading
point
for
wise.
like
Yes, Ashwin. Hello.
Can you,
Can you hear me? Hello. Hello, Ashwin. Is there any network issue from your side?
I'm saying is instead of putting it like four separate headings, can we just put
Yes.
position time graph and velocity time graph for object at rest, and then write those two graphs, and then put a second heading for those two?
Yes, good. In the first point, you have to give the heading like position time graph when object is at rest and draw the graph. After that, in next point, you have to write velocity time graph when object is at rest and draw the graph. Then in the third one, you have to write position time graph when the object is moving with a constant velocity and draw the graph. After that, you have to know write it as velocity time graph when object is moving with a constant velocity. So like this, you have to note down it in four different point wise. Okay?
Okay.
Yeah, please do it. Then Ashwin.
Yeah, I'm finished.
Okay. So now let's see here. There is a note given here. Okay. It said that if the force of friction is zero, a net force will have uh, to be applied to an object at rest to set it moving. Okay. But once the object is moving, no further forces where it is force is required to keep it moving with a constant velocity. However, to change the velocity means magnitude or direction, or to stop a moving object, a force will have to be applied. Okay, so did you understand this point? Ki suppose when there is a ball which is at rest, so if it is either it is raised, it's mean the frictional force is continuously acting on it. Okay, so that's why it is on rest. If you will if the friction force becomes zero, then at that time the ball starts to move. Okay, and if there will be no frictional force come in contact at that time, then it will continue to moving with a constant velocity, means there will be no change in velocity, means its magnitude or direction. Okay, or to stop a moving object, a force will have to be applied. Okay, is it clear? Did you understand this point? You are
Yeah.
on mute. Huh. So after this, let's see here. uh, there are some questions given here. Okay, so let's discuss is when an object is moving with a constant velocity, is there a net force acting upon it or not? Can you please tell me?
When an object is moving with a constant velocity,
Yes.
mm, yes, there can be a net force
When an
acting.
object is moving with a constant velocity, is there a net force acting upon it?
Uh, I mean, yes, there could be, right?
No. If it will act, then its velocity will change, right? uh, you can understand it like if the frictional force, if we will talk about the frictional force, okay, act on it, then after some times its velocity become to zero and that object will become to the rest, right? But here the
Okay.
moving object, the object is moving with a constant velocity, right? It's mean
Yeah.
no force is acting on it. Okay, okay, according to the Newton's first law. Because as we learned na just now in the beginning of the class, ki when an object is moving, it will continue move, it will continue the motion unless a force will applied on it. Okay,
Mm-hmm.
Is that clear?
Yeah.
Did you understand it? So
Yeah.
here we can say that no, there is no need for a net or unbalanced force. Okay. The second is you have to do all these three questions in your copy as a homework. Okay. Here just we will discuss it. Okay.
Okay.
And but as a homework you have to do it in
Okay.
your fair copy and you have to send me the photo. Okay. Yeah. Let's say
Mm-hmm.
here, suppose no net force is acting on an object. Okay. Which of the following situation are possible? Object remain at rest if at rest. Object keep moving with a constant velocity if already moving. Object is moving with a constant acceleration. Suppose no force is acting on an object. Which of the following
Mm-hmm.
situation are possible? Object remains at rest. Objects keep moving with a
Okay.
velocity if already moving, or object is moving with a constant acceleration.
Three. Object is moving with a constant acceleration.
Sure?
Yeah. Because if it moves with a
Constant
constant.
acceleration. If it will be constant acceleration, it's mean it will be constantly accelerate, or when it will be constantly accelerate, then its speed will change, na? And automatically there will be change in the
Which are
velocity.
possible, okay. Which
Huh?
are possible. I thought it was not
Yes,
possible.
which are possible. So this first point is possible, right?
Okay, the
When
first two
no
are
force is
possible, the
acting
third
on
ones
it,
are possible. Yeah.
remains at rest, it will be at rest. है ना? The second is कि object keep moving with a constant velocity if already moving. These two are
Yeah.
possible, right? According to the Newton's first law. But here when
Yeah.
it will be constant acceleration, it's mean its velocity change steadily over time, right? Causing its speed to increase or decrease. Okay, so that's why this will be not possible, na? Because here there is no net force. Okay, there is no net force, so this case is not possible. Did you understand it? These two are possible. Did you understand or any doubt?
Yeah.
So you can do it now by yourself. You can explain it
Yeah, I
now.
understand.
Okay, good. In
Yeah.
the real world, it is
Yeah.
difficult to find a situation when no force are acting on an object. Okay, it is difficult, right? Because if an object is at rest, it's mean a frictional force is acting on it. Okay, that's why it is on rest.
Mhm.
Otherwise, in a slope or in a slide, it will roll. Okay. So by applying
Yeah.
additional force, a condition can be achieved where the net force on the object is zero. Explain with the help of an example. In the real world, it is difficult to find a situation where no force are acting on an object. But by applying
Mhm.
additional force, a condition can be achieved where the net force on the object is zero. Explain with the help of an example.
If an object is like, for example, a car is like
Hmm?
it's just idle and this is parked in a certain area, it net force can be zero.
Can you please repeat it?
If a car is just like idle and sitting apart, then it can be also an example of net force of zero because it's just sitting there and different forces are acting on it, like the
Then
gravitational
car will
force.
move or not? When the net
The
force will be
car will
zero.
not move. The car will not move. Will be parked.
Will not move. Very good, है ना? So suppose there is a car, okay, on a road
Mm-hmm.
and it is in stop position. It's mean ultimately a frictional force is applied, right,
Yeah.
in the opposite direction. And when you apply a force which will be equal, whose magnitude will be equal to the magnitude of the frictional force, then the net force will become zero, right? So in this way, in this condition the car will not move, है ना? The same example we learnt in the above, right? uh, this example I think, a person is exerting a force on a moving box in the forward direction which is equal to the force of the acting between the bottom surface of the force and the floor. Will the box continue moving or not moving, or will it come to rest after some time, है ना? So here it was moving, the box was moving, but here the condition is net force of the zero, है ना? Where the situation no force is acting on an object, yeah. So you can write that one also, okay? Either the object is moving or not, the main thing is कि net force should be zero, okay? Is it clear now,
Yeah.
or any doubt?
Yeah.
So let's see here, it said that
No.
Newton's first law of motion describe the motion of objects. Okay, describe the motion of object in the absence of a net force. It is natural to ask what happened to the motion of an object when there is a net force acting upon it. Newton's second law of motion address this issue. Okay, is it clear now?
Yeah.
So is there any doubt in this one?
No.
No? Okay. If there is any doubt, then please tell me.
No.
Okay, let's see here. So now we will learn Newton's second law of motion, है ना? Leave some space on your yeah. अच्छा, you are noting it in your class or copy or homework copy?
Classwork.
Class or very good. Then you can write the next point, Newton's second law of motion. Okay. And when you will do it in your homework copy, then first note all the points regarding the Newton's first law of motion. After that, please do these questions and then do for the Newton's law of motion when you will do in your fair copy, okay? But as you are doing it in your classwork or rough copy for now, then please give the heading Newton's second law of motion. And let's see here what it say. You know that a force can set an object in motion, bring it to rest, or change its velocity, right? A change in velocity means that the object is
Yeah.
accelerating, है ना? This point I explain you in this one, the third one. Here the object is moving with a constant acceleration. Okay? So object is accelerating, okay? Thus a force produces acceleration, okay? But what if the relation between the net force acting on the object and its acceleration? So let's see here. Think as a scientist, okay? Let's first we will discuss this part. If from our everyday experiences, you know that if a ball is pushed gently, it moves slowly starting from rest, right? It's mean the acceleration due to force applied by you in small. On the other hand, a strong push result in the ball is starting to move fast, okay? That is a large acceleration due to nest applied for by you, the force applied by you. So based on your experience, you can make a hypothesis, okay? You can make a hypothesis that for the same object a large force result in large acceleration, okay? Mean, or a smaller force result in smaller acceleration, okay? Now how can you test your hypothesis? So you will have to think of an activity where you can apply forces of different magnitudes on the same object, okay, and the same surface to find the resultant acceleration, okay. How you can apply forces of different magnitudes, you have to learn in earlier grade about gravitational force, right? So
Yeah.
with which the earth pulls an object towards itself, it is called the weight of the of an object and is different for different objects, okay? Hence, you can use weights of different magnitudes to apply forces of different magnitude. Is it clear?
Yeah.
Okay. Now let's see the experiment, and with the help of this experiment, we will try to understand the second law of motion. If you want, you can demonstrate this experiment by yourself, okay, at home.
Mm-hmm.
So this activity is recommended to be performed as a classroom group activity facilitated by the teacher, okay. If you want to do it by yourself, you can do it. Here, what you have to take four balls bearing wheel, okay, two pencils and empty cardboard box to make a card, a paper cut, pieces of a pipe to use pulley, a length of thread, some coins or other objects to place in cup, okay, and
Mm-hmm.
a weighing scale to measure the mass, okay. Insert the two pencils through the slides of the box like this, as you can see here, okay.
Mm-hmm.
Box near to the bottom to fix as axles and attach a wheel to each of their free ends as shown in figure 6.17a, okay. This one, as you can see here, it is attached, right, the four wheels, okay. Now, if the wheels are loose, wrap some adhesive tape at the pencil end to fit the wheel tightly. Attach a thread to the front end of the box with which you can pull the cart. Okay. Now draw a line at one end of the table which will mark the starting point for the cart. Pull the thread over a small pipe attached at the other end on the table 6.17b. Okay. To this thread, attach a cup in which you can put some objects. As you let the system go, the cup will move down, है ना? As you can see here, okay? Due to gravity force by gravitational force by the earth on it, and the thread will pull the cart with a constant force, okay. Now measure the mass of the cup along with any other objects put inside it with the weighing scale, okay. Now start recording a video of the cart in slow motion. Release the cart from the starting line and record the video until it reaches the pipe at the other end of the table. Okay? Is it clear? Did you
Yeah.
understand it?
Yeah.
Now read the time when you
Yeah.
release the cart and when it reach the end of the table by seeing the slow motion video and record the difference as T1. Okay, this time T1, this will be T1. Now double the mass of the cup with the object
Done.
inside it and repeat step 5 and 6, okay, to record the time difference, and it will be denoted by T2. Now using the values of the time measured, let us do some analysis, okay. So for both cases, the cart starts with zero velocity, right? Means initial velocity was 0. So it will be denoted by u equal to 0, okay. And travel the same distance means it will be denoted by s. If a1 and a2 are the acceleration in two cases respectively, using kinematic equation, we will obtain the equation. This is the very important equation, okay. S equal to half a1 t1 square, and for the second case it will be s equal to half a2 t2 square, okay. So with the help of this equation, the right part of this two equation will be become equal, right? And when you will solve it, it will be a1 by a2 equal to t1 square by t2 square by t1 square, okay. Is it clear? You have to note down these points, okay. First this one, then this one. You can when you will solve this two, you will get this one, okay. So substituting the value t1 and t2, you find that when you increase the force of the same mass of the card, the
Wait.
acceleration
Can you
increases.
can you can you show me how when we add?
Sure. Here it will be half a1
Mm-hmm.
t1 square, it will be equal to half a2 t2 square, right?
Can you show me how an you like compile this case is supposed to take the full one?
Just wait a minute. It's an urgent call. Wait, wait.
Okay.
Hello. Hello.
Now,
Yes. So as you can see here, s equal to half a1 t1 square, right? S is the distance, है ना?
yeah.
So this is for the first case, and this distance is
Mm-hmm.
for the second case. Okay. As here, the left side, in the left side, in both case it is s,
Mm-hmm.
right? Means the distance. Okay. And here, so for both case the distance is same, right?
Yeah.
So this right part will become equal to each other, na?
Mm-hmm.
Okay, so that's why I have written here ki half a1 t1
Yeah.
square, it will be equal to half a2 t2 square. Okay, this half and this half will be cancelled. Okay, or you can also assume it like when this 2 come in the right hand side, it will
Yeah.
be 2 into 1 by 2, na? So that's why 2 2 cancel, and it will be a1 t1 square equal to a2 t2 square.
Yeah.
Okay, so when you will solve it, it will be a1 by a2 equal to t2 square by t1 square. Okay, so in this way you will get this formula. Okay, is it clear or any doubt?
Mm-hmm.
Is it clear now?
Okay.
Okay,
That's
so you
clear.
may
Yeah.
conclude
That's
that the
clear now.
acceleration of an object is fixed of fixed mass increase as the net force applied on it increase. Okay, so now think as a scientist
Okay.
कि apart from force, does acceleration depend on any other factor? Okay. For everyday experiences, you
Mm-hmm.
know that with the same magnitude of force, it is easier to set lighter objects in motion than heavier ones. Okay. This lead to a second hypothesis that for the same force, a smaller mass has a large acceleration or a large mass has a smaller acceleration. Okay. So now how can you
Mm-hmm.
test your hypothesis, this second hypothesis? Okay. So this way will prove or test by this experiment. Okay now? Is it clear?
Okay.
Or any doubt?
Yeah.
Is there any doubt till here?
No.
Please confirm me.
No.
No.